Reference angles are often confused with coterminal angles, okay, because they're somewhat similar in the way that they're kind of set up. But a reference angle allows you to identify angles, and they're designated as theta prime, is the way that that's described. It's just an angle with an apostrophe. And the reference angle allows you to find measures in any of the other quadrants beside the first quadrant. So remember, you're looking at quadrants 1, 2, 3, and 4. Okay, just by using as a reference angles from 0 to 90 degrees. Okay, so every trig ratio that we're looking at will have a reference angle, and the reference angles will be kind of compared to or based on either angles in quadrant 1. And the way that you can look at reference angles, anything in quadrant 1 is just the angle itself. So if I looked at this angle right here, and let's say this is 40 degrees, okay, there's no reference angle. You don't need to think of anything like that. Now, if I move to the second quadrant and I create an angle, so let's say this angle in orange is 100 degrees. Okay, the reference angle is designated as the angle that's formed when you draw a vertical line from the angle to the x-axis. Okay, so when you look at this vertical line from this angle, and it can be anywhere on the angle, but straight down to the x-axis, okay, the angle that's formed, the central angle that's formed there, is what's called your reference angle. Okay, so this angle, theta prime, is the reference angle. Okay, so how would we find the reference angle for any angle in quadrant 2? We're going to take what? This angle right here is the whole angle from 0 to 180 minus the original angle. So to find the reference angle in quadrant 2, 180 minus theta. Now, if we were dealing in radians, so this is degrees. If we were dealing in radians, what would the formula be for a reference angle in quadrant 2? Instead of 180, how many radians? Pi minus theta. Okay, so there's your reference angle for this. Okay, let's take a look at questions, Saber. In order to find this angle right here, this theta angle, we're taking the whole angle, and then we're subtracting this portion of it, theta. Well, the whole angle is 180 or pi, because it's this full half of rotation or semicircle. And then we come back the reference angle, and the way that we find that is we remove 100 from that 180, and that's going to give us, yeah. Okay. Right, when you're looking at an angle in quadrant 3, okay, so let's say we look at this angle here. So now this one is extending all the way here. So let's call this an angle of 200 degrees. Okay, the reference angle is the angle that's the central angle that's formed when we, again, we connect the terminal side with the x-axis. So here's the terminal side. Here's the x-axis. So here would be the reference angle for 200 degrees. And so what would we have to do in order to find the reference angle of this green angle, an angle in quadrant 3? We take, again, all we know is this original angle measure. So here's the original angle measure, 200 degrees. What's this reference angle going to be? 200 minus theta. So if we take the 200 is that given angle. So if we take 200, our theta measure, what are we subtracting from it to be left with just this reference angle? 180. So if we subtract 180 from our original angle, we get our reference angle in quadrant 2 or in quadrant 3. So in terms of radians, we're going to take theta and subtract pi. Say that.
Why are you using theta?
Theta represents the original angle. So in this is your original angle. And then theta prime is the reference angle.
What is the original angle? What is
The original angle, the original angle was 200 degrees. And in this orange one, the original angle was 100 degrees. In quadrant 1, the reference angle and the original angle are just the same thing. You don't even need to use a reference angle. The reference angle just allows you to express each angle in terms of an acute measure. So a measure from 0 to 90 degrees. So when we looked at this, in this first one, in the black, in quadrant 2, if our original angle was 100, what is our reference angle? 180 minus 100, which is 80. And in our quadrant 3, if our original angle was 200, what is our reference angle going to be? 200 minus 180, or 20. All right, so the final instance is if we have an angle that lies in quadrant 4. So again, we're looking at this full rotation all the way through here. So let's say this is 330 degrees. So that's our original angle. When we form our reference angle, it's formed with the same terminal side, but we're finding the other side is the x-axis. So whatever x-axis forms your acute angle. So here is theta prime for this light blue. And so how would we find this measure right here? It's an acute angle. What would we have to do to find what this measure is? Okay, now, careful. The 330 minus the 180 is going to give us this large angle here. Okay, good. So on this, if we're looking for our degrees, it's going to be the whole thing, the whole rotation, 360. So again, we're coming all the way to 360 and then back, minus the original angle. And that's going to give us our reference angle. So in terms of radians, 2 pi minus theta is 120. What is the reference angle? Okay, so if that's your problem, how would you find the reference angle for that? Which quadrant will 120 fall in? 2. So what equation are you going to use? And that leaves you 180 minus 120 is 60. Correct? Yes, say that.
How did you decide to get 2 pi for the radian?
Right here.
Yeah.
Because in order to find this reference angle here, what you're doing is you're taking this whole rotation all the way to here, 360, and then when you remove this portion of it, the original angle itself, you're going to be left with that reference angle.
But over there you did.
Right, each one has a different equation relationship.
How are you supposed to know which equation?
Well, I'm showing you how you can derive it here, but then if you use each of these equations for the correct quadrant, that's all you have to do. Okay, so let's say we took the following example. Okay, let's say that your angle is 5 pi over 3. What would the reference angle be for that? Which quadrant does this fall in? Again, you'll keep your answer in terms of radians. So which quadrant will this fall in? Okay, so let's think in terms of thirds, right? So here's 1/3 pi, here's 2/3 pi, here's 3/3 pi, 4/3 pi, 5/3 pi. So it's going to fall in quadrant 4. So in order to solve this, we're going to take 2 pi and subtract 5 pi over 3. Okay, well, what is 2 pi in terms of the same fraction, thirds? How many thirds is 2? 2 is 6 thirds, right? So if you take 6 thirds pi minus 5 thirds pi, you get 1 third pi. Right? So this would be your reference angle for 5 pi over 3. Angle, and we'll put it into this quadrant. So we know it's, let's say, 5 pi over 7. Right? That would be an angle that falls here. Right? Because it's beyond 1/2 of pi, but not quite 1 pi. Okay, so if you wanted to find the reference angle here, you take 2 pi, or I'm sorry, in this case you take pi, which is how many sevenths? 7 pi over 7. So if you think of it in terms of the same fraction that you're dealing with, and we're going to subtract the 5 pi over 7, what is our reference angle going to be? 2 pi over 7. Now, if we wanted to find an angle in quadrant 3, so again, let's say we're keeping it in terms of radians. And so let's use 12s. Okay, so what would be an angle that falls in quadrant 3 in terms of twelfths? Some pi over 12. In terms of 12. Okay, how many twelfths gets you to the 180 degrees? 1 pi, which is how many twelfths? No. Well, 15 would work for one of them, but how many twelfths get you to this 180? Or 1 pi? It's 12 twelfths, right? So, 12 twelfths gives us here. So anything beyond 12 twelfths up to, what's halfway point of twelfths? 6, right? So anything from 12 to 18, 6 more than 12, is going to work. So 15 would work. I'm not going to use 15 just because you could simplify that fraction, but let's use 17. Okay. So if we use 17 pi over 12 as our angle, it's going to fall in quadrant 3. And so if you're looking for our original angle, 17 pi over 12, and what are we going to remove from it? 1 pi, which is how many twelfths? 12 over 12 pi. And so what do we get for our reference angle? 5 twelfths pi. Okay. You guys kind of seeing the pattern for those? Again, you don't have to memorize these relationships. I showed you how to derive them, but if you have them written down in notes that you can reference, that will be just fine.